Here's one for you to try. We have 3 over x plus 3 equals 12x plus 19 over x squared plus 7x plus 12 minus 5 over x plus 4. So I want to give a little bit of direction before we pause the video here. So let me bring up the steps to solve these. Here they are. So you want to find the least common denominator first and then clear fractions by hitting both sides with that least common denominator. Another hint I'll give, which you may or may not have noticed, is that you need to factor this first. Factor. Okay, so factor that. That'll help you get the LCD. Okay, so pause the video, try it on your own, and see if you can get this to work out. Okay, so let's do it together here. So I noted that we should factor that, so let's go ahead and factor this right now. Okay, so can we factor this? We want multiples of 12 that add to 7. So two numbers that multiply to 12 but add to 7. How about 4 and 3? Plus 4 and plus 3. Okay, now we can move on to our LCD, the least common denominator here. Okay, so the way we find that is we add in our first one, x plus 3. All right, and then we ask, what do we need to add to this so that we include everything in the next term? Well, we have our x plus 3, but we need to add in an x plus 4. So we add that in, and now we have an x plus 3 and an x plus 4. Now we move on to our next term, x plus 4. Well, that's already included in the LCD, so we're good to go there. Thus, our LCD is x plus 3 times x plus 4. Okay, so now we multiply both sides by x plus 3, x plus 4. It's our LCD there. A little busy up here. X plus 3 times x plus 4. And that's going to clear fractions for us. So I'm going to have to do a little bit off to the side here. X plus 3 times x plus 4. Okay. Now notice that when we multiply this first term by x plus 3, x plus 4, the x plus 3's cancel. So that leaves us with 3 times the quantity x plus 4. So it's important to leave those parentheses around those numbers so that you get the 3 multiplying through to the entire quantity there. All right. Now on the right side, we distribute this term through to both of these inner terms here. And notice on the left one here, on this x plus 4, x plus 3, it's going to cancel out the entire denominator. So let's see, so that gives us equals, all right. So we're left with 12x plus 19 minus, okay, 5 times parentheses, and now the x plus 4's cancel, leaving us with x plus 3. Note that all the denominators are gone. Now we can solve this out. So let's distribute the 3 through, let's distribute the 5 through. So 3x plus 12 equals 12x plus 19 minus 5x minus 15. All right, let's do a little more combining like terms here. So we'll combine those together. Leave the left alone here, 3x plus 12 equals, all right, how about 12 minus 5 is 7x. Looks like plus 4 there. So I'm going to get all the x's on the right side, so subtracting 3x gives us 4x, and then I'm going to subtract this 4x from both sides. That gives us 8 over here, and divide both sides by 4 to get x equals 2. Is that what you got? I hope so. But we're not quite done yet, because we have to do one last step. Check your answers when you're solving rational equations to make sure none of these give us 0 in the denominator. So this is okay, right? We could plug into all these different denominators. None of these are going to give us 0. The one that would be problematic is if we had some stuff over x minus 2, for instance. Then if we plugged in 2 for x, it would give us 2 minus 2. So that's what we're looking out for. Luckily, we don't have that. So this answer checks out, and it is indeed our answer. You don't have to plug it all the way in and solve it all the way through. You're just looking for places where it would give us 0 in the denominator.